Hello and welcome. In this video, let's explore system design best practices, covering industry standards and proven methodologies to help you build scalable, reliable, and maintainable systems. We'll delve into key principles that guide the creation of robust and efficient architectures. Let's discuss scalability principles. First, horizontal scaling. Instead of upgrading the existing hardware, you add more servers to handle the increased load. Second, load distribution, which means that you distribute incoming requests across multiple servers to prevent any bottlenecks. This ensures that no single server is overwhelmed, maintaining optimal performance. Now, let's explore caching strategies, specifically using the cache-aside pattern with Redis. In this code example, the function get_user_data retrieves user data by first checking if it exists in the Redis cache. If the data is found in the cache, it's immediately returned, reducing database load. If not, it fetches the data from the database, stores it in the cache with an expiration time of 3,600 seconds, which is 1 hour, and then returns it. Caching frequently accessed data like this significantly reduces database load and improves response times. Let's explore database design patterns, the first being database sharding. For improved performance, it splits large databases into smaller, manageable pieces. Second, read replicas, where read-only copies are created to distribute the query load and reduce latency. Using these patterns helps in optimizing database performance and scalability. Let's take a look at Microservices Architecture. Here, we have a user service responsible for authentication and profiles, an order service for transaction processing, and a payment service for financial operations. These services operate independently and communicate with each other. This architecture enables independent deployment and fault isolation, which enhances system resilience. If one service fails, it doesn't necessarily bring down the entire system. Let's consider the principles of API design, specifically RESTful API endpoints. As you can see, we have various routes defined using standard HTTP methods. Get/API/version1/users to retrieve all users. Get/API/version1/users/ID to retrieve a specific user. Post/API/version1/users to create a new user. Put/API/version1/users/ID to update a user. And delete/API/version1/users/ID to delete a user. These consistent naming conventions in HTTP methods result in predictable API behavior. Let's explore monitoring and observability with 3 key pillars. Metrics, which involves tracking performance indicators and system health. Logging, which is capturing structured events for debugging. Tracing, which is following request flows across services. By implementing these practices, you gain deep insights into your system's behavior, enabling proactive issue resolution. Now let's focus on security best practices. Authentication involves implementing JWT tokens and multi-factor authentication for secure access. Data encryption means using TLS/S/L for data in transit and encryption for sensitive data at rest. These practices protect your system and data from unauthorized access and potential breaches. Let's consider fault tolerance and resilience using the circuit breaker pattern. In this code, if the circuit breaker is open, the system returns a fallback response. If it's closed, it tries to call the external API. If the API call succeeds, it records the success and returns the response. If it fails, it records the failure and raises an exception. This pattern prevents cascading failures by isolating problematic services and providing fallback responses. In summary, remember to design for scalability from day one, build with observability and monitoring in mind, and prioritize security and fault tolerance. By applying these principles, you can build robust, production-ready systems that meet the demands of today's complex environments. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.